Okay, we are live on YouTube.
Welcome everybody to House Energy and Digital Infrastructure. It's Wednesday, May 14th. And we are doing something kind of neat and different today. We are taking a class and we're going to receive some training on cybersecurity, artificial intelligence, and information warfare for policymakers. And we're going to be joined with some experts from the Applied Research Institutes at Vermont's own Norwich University. So we'll quickly go around the room and introduce ourselves, including our colleague, Rep Campbell, who's joining us online, and our committee assistant. And then we will turn the mic over to you, so to speak. And I know that you will let us know later in this morning's coursework when you would like us to go into executive session for a more confidential part of the curriculum. So thanks again for joining us. This is a really unique opportunity. We're excited. And I am Representative Kathleen James from Manchester.
Richard Bailey, Memorial 2.
Chris Morrow, Wyndham, Windsor, Bennington.
Michael Southworth, Caledonia 2.
Christopher Howland, Rutland 4.
Darren Torrey, Washington 2.
Graham Klutner, Chittenden 13, Burlington.
Horace Billiam, Wyndham 2.
And I'm Scott Campbell, representative from St. Johnsbury.
Jack Locker, committee assistant.
All right, we are all yours. And as I mentioned earlier, we're broadcasting live now on YouTube until you tell us it's time for executive session in a couple of hours.
Great, thank you very much. Hi, I'm Phil Sussman, and I'll have each one of the folks here introduce themselves quickly. So it's John, Sherman, Rachel. John?
Hello, John Kidder. I'm the Director of Information Operations Research at the Applied Research Institute.
Hi, I'm Rachel Sickler. I'm a Senior Developer and Machine Learning Engineer at Newari.
Rachel, you may need to turn your mic up.
Oh no. Does this fix anything? Okay.
This fixes everything.
Great. I'm Rachel. I'm a Senior Developer and Machine Learning Engineer at Newari.
Hi, and I'm Sherman Patrick. I'm the Vice President for Strategic Partnerships, and I'm here for support and note-taking and lurking for our wonderful subject matter experts. I'm really excited to witness this myself.
Thank you. So the order that we're going to go through this morning will be Rachel's going to talk about artificial intelligence, give some background, and then some suggestions going forward. I will cover the concepts of cybersecurity, and we'll finish up with John in a discussion of information warfare and nation-state-based activity. So I'm going to hand it over to Rachel. Rachel, I know you want to be able to share some slides. Will Rachel be able to share slides?
Yep, I've given her co-host sharing permissions.
Thank you, sir. Rachel?
Let's see if I can figure out how to do it.
Looks
Do you
good.
see my slide?
Yes.
Or do you see it? Do you see like the notes screen? And I only have one screen, so do you see? Do you just see the slide, or do you see my notes?
It's not.
What? Sorry.
We can only see the main slide, not your private notes.
Great, thank you. As I said, I'm Rachel. I'm going to be talking a lot about AI here and data. I tend to be a little bit of a fast talker, so feel free to like jump in and ask questions. I'll try to take a breath after every slide so you feel like you have an opportunity, even if I speed through these. Hopefully a lot of this will be a little bit of review and then a little bit of something extra. So what makes AI different from all other software? The difference is only how it's built. With traditional programming, we collect the requirements to define business logic.
Rachel, sorry. I'm sorry to interrupt.
Yeah.
Would you need it a little bit louder?
Yeah, please.
Yeah. Could you turn it up a little bit more? I'm sorry.
I don't know if I can.
Okay. We turned off We turned off our fan in here.
Oh, let me see if there's anything I can do on my
I
audio
think it's
option.
better now.
I think that's.
We had a big air filter going.
Okay, let me see if I
Okay.
can just like expose my earbuds.
Okay.
Okay, so with traditional programming, we collect requirements to define business logic, review the inputs for all the cases, and produce expected outputs based on those inputs. With machine learning, those outputs become part of the input. So you input all the cases with their expected outputs, and the machine learning function writes the logic for you to get from the data to the answers. And the result is a function that best approximates those cases. But at the end of both of these processes, you have a function that takes data as inputs, performs some logic, and outputs an answer. So in the image here, the bubble that gets deployed to a production system or into an application in both cases is this orange rules bubble. Same for both logic-based systems and machine learning.
And the rules are, I think you can assume we're lay people. So
Yeah, the rules are sort of like if you think of if you've been through like IT projects before, trying to define trying to like come up with an automated process. Somebody comes and collects your requirements. Those are your requirements. How an expert would get from point A to point B. Let's talk a little bit about how to create a new capability. So the purpose of creating any new capability or streamlining existing processes is to create value. This may not be a popular opinion, but I'm of the mind that the purpose should never be just to use AI. If AI or machine learning turns out to be the right solution to a problem, great. It shouldn't be used in place of creating business requirements and assessing for the right solution. Since the difference between a machine learning solution and traditional software is only the implementation details, the right project for AI is a problem where the inputs and their expected outputs cannot be mapped by an expert. That's when you need statistics to find those correlations for you. The idea of solutioning is where you start with a solution instead of the problem. And it's common when forming a new project team, finding the problem or the purpose of creating a new capability and the why behind that problem and working your way towards the solution will always create value as long as your problem is well defined. A little bit about terminology. So these terms are often used interchangeably or incorrectly. AI can include anything from heuristics implemented with if-then conditional statements to methods that learn from human experience to inference methods that learn from their own experience. Vanilla machine learning is explainable. We can tell which feature in the data led to the predictions and how much emphasis or weight was put on those features. Deep learning is called a black box method because it is usually impossible, or at least like really difficult to understand why the algorithm outputs the values it does. Many in the data science community value explainability over performance. Like a 1 or 2% boost in performance or accuracy is not always a justification to use a black box method. Something that small could even be attributed to pure chance. Deep learning is used in things like autonomous vehicles, deepfakes, and virtual assistants, as well as generative AI like large language models. So quick review on the basics of machine learning. Supervised learning is when the data used to train the model is labeled. This maps the input to the output. Two examples of this you see here are classification and regression. In classification, your output is a class or like an in group or an out group. So if you're looking for triangles, you want them to be up in that red area. And if they're looking for circles, you want them to be down in that blue area. Regression, the output is a number. Unsupervised learning, the data used to train the model is not labeled, so you don't know the answers. The model discovers patterns and information that was previously undetected. And then there's reinforcement learning, where labeled data is optional. The model is created through feedback by rewarding desired behaviors and sometimes punishing undesired ones, maximizing a score. It's a little like a video game, but the best example of reinforcement learning is how you would train a dog. So if you want to teach a dog a trick or to sit or to fetch, your dog's trained through reinforcement learning. First, you tell the dog, the agent, to do an action, sit, and if it does what you want it to do, it gets a reward. You give it a treat. The goal is that the agent chooses the best possible behavior given the situation. This is different from supervised learning because it's all about making decisions sequentially. The output depends on the state of the current input, and the next input depends on the output from the previous input. And just as a side note, I just want to mention that the agent here shouldn't be confused with agentic AI, which you may have heard of, which is that can use generative AI along with other tools to pursue a goal or make a plan or take actions. People often conflate AI with generative AI. We know that's not the actual definition, but when you're having a conversation about these tools, you should always try to get on the same page about what AI means in the context of the discussion. This can sometimes be difficult if it's phrased like a pop quiz, but with technology changing so quickly, you should ensure you know what's being discussed.
Rachel, sorry, I have a question about this. Is every smaller circle within the circle a more complex or advanced version, but they're all within AI? I don't understand the circles within the circles.
Oh yes, this is saying that a large language model is generative AI, and generative AI is deep learning, and deep learning is neural networks. Yeah.
But they're successively more advanced or clearly defined or smaller, like subsets of the larger thing.
Yeah, you could look at it that way.
Okay. I will look at it that way.
So we're using tools made through deep learning every day. Many modern recommendation engines are deep learning models. So when you click on a product on one site and then you immediately see ads for that product on your social media, that's all brought to you by the sale of your data to be used in recommendation algorithms. Face ID to unlock phones and mobile apps are also examples of deep learning in action. It's important to understand that the basis for deep learning is linear regression. It's deep because it's composed of layers, and each layer represents a single linear regression's weighted output. Generative AI can help you create images that aren't possible in the real world, hear a voice that can no longer speak, and help you workshop an email you can't seem to word just right. What makes these models different from other models? Generative models are still making predictions, and what they essentially do is predict the next word in a sentence based on the previous words or the next pixel in an image until the image matches what it knows, approximates what the user requested by referring to its training data. The request is called the context. Models can be very specific or they can be very general. Large general models are called foundation models. These are usually the basis for other models that are trained to specify them on a task. You may use GPT-4o or Llama as a base model, and then use transfer learning with documents from your organization that has created with documents that your organization has created for their customer service staff to fine tune a chatbot that writes well, which would be the ChatGPT component, and knows what a customer service agent should do in different scenarios from your documents. Another way to use pre-trained foundation models is by implementing retrieval augmented generation, called RAG. This is how most companies use public foundation models today. It adds a layer to the model's response system and gives it access to a database of documents to refer. This helps minimize incorrect responses and can be used to provide explainability to those black box models. The databases that they refer to are called vector databases. AI-generated art, text, and video are the newest obsession of Silicon Valley, but does this technology make work better? Does it make it easier? Does it increase profits or save money? The answer seems to be, it depends. I'd also like to discuss the anthropomorphizing of AI. People state, as I have already in this presentation, that AI knows things and it hallucinates. It does neither. AI cannot hallucinate. It's just wrong sometimes. I think this is a clever trick that big tech has played on us because it makes it seem like these are fallible creatures that deserve some grace. These are software programs that we should hold to the same expectations that we hold bank software to and email applications. What if some of your emails went to a person you didn't send them to, but you emailed really often? Would you give Outlook the same grace? I don't think so. The fact is that creating generative AI models from scratch for use in like the customer service chatbot is cost prohibitive to most organizations. Even hosting a model to use is cost prohibitive to most organizations. The cost of inference in many cases is more than 15 cents per query for image and text generation. These large models can really pump up the price of asking a question. Like, can you imagine if can you imagine the money you'd have if you charge 15 cents every time somebody asked you a question and you didn't even have to get it right?
So you mean, could you explain that again? Sorry. So you said 15 cents per inference. So
yeah, every time you type in a question to ChatGPT, it could cost as much as 15 cents or more.
so not, I was imagining the process of the programmers or whoever feeding the question into ChatGPT for the first time, you know, and then it knows how to answer that forevermore. You're talking about every time an individual customer or an individual person uses a chatbot to ask a question.
Mm-hmm. Yes.
And what is that cost? Is that, I'm sorry. I was just
Go
wondering
ahead.
if that's, is that the electric cost? What is it? What does that cost?
It's really the compute. I mean, like electric comes into it, but yeah, it's like the cost of all those computations on a server.
I'm sorry, go ahead, Rep. Campbell.
Well, I guess I'm just, yeah. How are those costs incurred? Is that a sort of a fraction of the cost of having that computer that does the computing, or what?
Yeah. Yeah.
Okay. All right. Got it. Thanks.
Rep.
Go ahead.
Tucker.
I was just going to ask about how the money flows, because when any of us type a question into our computer, we don't have to put a dime and a nickel into the slot.
Yeah. I mean, but these are hosted not on your personal computer. You pay by compute when they're hosted in the cloud.
I don't feel like I'm paying. Like, I've never paid. I use ChatGPT and I've never paid. Like, they never sent me a bill.
No, but they pay.
They pay. Exactly.
Yes. Yes, and right now you're using a free version of that because, of course, you're the product when you're using a free version of something. But I mean, it's interesting. I don't have the figures, but if you look up how much OpenAI loses on ChatGPT every quarter, I think you'd be surprised.
All right.
And Rachel, that
Bailey.
matters if for government that wants to institute a chatbot. We heard some talks about chatbots for Social Security earlier this year. The government then pays for all that compute. It's not like they're just getting the free ChatGPT version, or at least giving away the data to ChatGPT.
That's right.
Rep Bailey.
So my question is, we have an awful lot of computer upgrades that can be done, which are at various agencies. Can AI write any of that code any cheaper than a human? And can that get done quicker rather than having a 3-year time frame, but you get it wrapped up in a year?
It's possible. I can only say in my own experience, I've used a lot of the AI coding assistants. I think they're really fun, and I think they do get me started faster on a project. I've never had one produce code that runs right off the bat. I still needed my programming expertise to make the program work. So could they make you move faster? Maybe. I think it all depends on the programmers you have and how they use these tools and how they work right now and how well you define your business requirements. I think the idea that these coding assistants can replace developers might be a little far-fetched, because I don't think that the problem is that the programmers can't write the code fast enough. It's often a communication problem between what the business users want and what the developer understands they want. And I think there's a certain amount of conversation that needs to happen there, that you know, if you tell the chatbot you want one thing and it misinterprets it, you have to start over again with a chatbot. With a human, you can have a conversation over many months.
Thank you.
The last thing I wanted to talk about on this slide was AGI, Artificial General Intelligence. This is a term we're hearing a lot about now. It's mostly undefined, and I'm sure some AI lab will just make the claim that they have achieved it without predefining the metrics to what it is in the next 2 years. The large labs seem to be claiming a model that can automate more labor with a good as being a good thing. This is what we were just talking about with like replacing humans with technology. And in some ways, this is no different than any technology revolution we've gone through, and the economy has survived it all so far. The problems really start to surface when it happens quickly, where there's either no plan on how to feed and house people that aren't able to find work that AI has assumed, or perhaps even worse, the idea that the government will implement universal basic income to overcome the problem that tech has created while the creators get richer. OpenAI has even asserted that AGI should be a public good, but the public doesn't have input into its creation and use, and we're not benefiting from its sale right now, even though it wouldn't be possible without our data. It feels insincere that these companies who are clearly trying to profit off this technology are essentially talking out both sides of their mouths, saying everyone will benefit from this technology, while also admitting it will put people out of work, and they have no explanation for how that's a good thing. The real risk here is that companies might replace employees with technology that doesn't actually work or doesn't work as well as their employees. There are human factors for many jobs, like we just talked about, that get discounted as non-essential. And I think this could create a crisis where big tech grifts its way to the top, and both companies and workers suffer. I think this is part of like the AI bubble that the responsible AI crowd is really trying to sound the alarms about. I like to throw this quote in every presentation I give. George Box was a British statistician, and he wrote this aphorism in a paper as a reminder that reality is always more complex than we can model mathematically. This doesn't mean we should ignore the things that are wrong, but use our judgment to decide if a model is so wrong that it's not actually useful. Correlation versus causation. The thing about these models that they all have in common is that they only know correlation. They can't determine causality. They don't know that X causes Y, just that they trend together. This can be incredibly important when causal features of the data are left out, because you might still get a pretty decent looking model using predetermined evaluation metrics, but it's actually not working. This is why expertise matters when determining which data is important for the true outcome. The model can't know what you don't tell it. And this little graph is from a website called Spurious Correlations, which is like just really fun, fun little causal, non-causal graphs.
It's kind of freaky.
Yeah.
So how do you know if a model works? Well, first, what does works mean in the context of the problem you're trying to solve? Just because it can get a 1600 on the SAT may not mean it can help people find and fill a form on a website. This is why defining your problem is important. You should also define success before you begin testing a model to avoid any what we would call data snooping or data leakage. This can lead to overfitting a model to the test set, which just means that it won't generalize to data that isn't in your training set. When thinking about generative models, you need to evaluate how well it generates outputs that are useful, high quality, and aligned with its goals. A lot of generative AI users consider mainstream benchmarks, but also come up with benchmarks of their own or evaluation pipelines so that they can rerun prompts and tests with different models or iterations of models. Each use case should have a predefined success metric that is measurable. Supervised learning models are the easiest to evaluate because we have a set of data with the answers. There are formulas that consider a ratio of true positives and negatives to false positives and negatives that the team considering the model can choose from to determine a balance between risk and utility. For regression, you're typically looking to minimize an error metric. I don't like to stop simply at evaluation metrics. When we build models at Nuari, I recruit an expert on the situation to review a sample of the model's predictions and a few different outcomes at different confidence levels. Sometimes the labels on a data set are incorrect. Sometimes the model is consistently getting a certain type of outcome wrong, indicating we might need more examples for our model to perform the way we want it to. At Nuari, we believe AI should be used to augment processes to make them more efficient and perform tasks that humans are inefficient at or don't enjoy doing. We create cross-functional teams where the domain experts help inform the technology that is built to help them. The AI we create should be something people see as useful or a need, not just a solvable problem. The feedback I hear from a lot of people is like, why is AI everywhere now? And how do I get rid of it? You know, there's little chat prompts in every app that you open these days. You know, simply saying that it works and telling people it's great and futuristic doesn't make them want it. Let's talk a little about ethics. So while Bias is often conflated with discrimination. That's not exactly what it means. Bias can lead to discriminatory outputs, but bias actually refers to distributions in a data set that aren't representative of the predictions we're expecting. This can happen because data is created from human behaviors, which can reflect bias that lead to discriminatory outcomes. Sometimes the data of our past should not become the AI of our future. We may want to build a world where the decisions we make are based on something different than the decisions of those who came before us. Societies change, laws change, cultures change. There are a few different kinds of bias that are prevalent in machine learning. Sampling bias, making sure that the training data is representative of the population we're trying to model. Similarly, selection bias when the sample is skewed, so the results are too. Survivorship bias, this is selecting from which point in a process you select your data. That can skew your results because of attrition or dropout. Recall bias, when people don't remember what really happened. And of course, confirmation bias, where we don't properly account for the data because we think we already know the outcome. There are a couple types of bias in models specifically. Underfitting, when your model isn't learning from your training data. It's either not consistent enough or there is not enough of it to learn the patterns. This is really obvious when you see it happen when you're creating a model because your model metrics don't look good. Like your model doesn't look like it's performing well. With overfitting, your model is learning your training data so well that it's simply memorizing the answers and performs poorly on data that isn't your exact training set. This is harder to detect because at first glance, it looks like your model is close to perfect. We should also recognize that data that is representative of one population may not be representative of another. A model could be built for Montpelier, Vermont to predict traffic, and it wouldn't work for Burlington, and that's bias too. Bias can also be created during implementation. Developers and engineers make lots of little decisions as they clean data and write functions that create training data and train these models. They tune the models to optimize metrics. This, of course, isn't isolated to machine learning. All software is susceptible to this kind of bias, and this is why representation on engineering teams really matters. What about explainability and interpretability? If you ask about explainability during requirements gathering, I often hear that if the model works, then they don't need to know how the prediction is made. You could have the most robust model with validation steps and buy-in from the business during every step of the modeling process. But the moment the model makes a prediction that the expert disagrees with, the first question you're going to be asked is why? Explainability is about understanding the outputs of a model. In a language model, this might be weights given to words that a generative model chose or caused a classification. Interpretability is understanding the logic of the model's prediction. This is how inputs relate to outputs. Deep learning models can't do explainability or interpretability well or at all, and that's why we refer to them as black box. With the amount of data being collected today, data breaches are a very big deal. You could lose the confidence of your users if you don't have processes in place to protect the data they have entrusted you with. And as exciting as automation and AI are, we have to be mindful that some of this data is sensitive. Just because we can doesn't mean we should when it comes to optimization with sensitive data. And on the note of just because we can doesn't mean we should, you may be able to fund creating an AI model from scratch and hosting it. Does that mean you should? There are other details to consider when making this decision. Climate, for one. Many of the companies creating large language models are using a lot of the same data. They're all scraping the same internet. Models using the same data all have the potential to be just as good at predicting as each other. The cost to the environment of the machines it takes to scrape this data and store it, and the huge processors it takes to train these models and host them is all part of an ethical conversation happening around these products, especially since much of this processing is happening in places where it's hard to cool these machines. Microsoft even considered building data centers underwater at one point. Companies like Google are building data centers in places that already have water scarcity, like Uruguay, where during droughts, people are drinking bottled water if they can afford it, or contaminated water if they can't, because these data centers are using all the drinking water. When we use these models, we cast the vote that we think that those practices are okay. And all the major AI producers are building data centers with similar tactics.
Rachel, what's the extent to which the centers are being built, overseas versus here in the States?
Ooh, I'd have to get back to you on that one.
Thank you. Yeah, I'd be curious to know.
Yeah, I'll get back to you on that. That's an interesting question.
Rep Bailey?
Well, why would they be building an AI center in Uruguay where there is no water?
Because labor is cheap there, and land is cheap, and they sometimes get more favorable government regulations.
Electricity.
Mm-hmm. Let's see. Testing these models. Sometimes models do things we didn't expect them to do. Testing for a variety of real-world scenarios is so important to ensuring your model isn't creating biased outputs. You should train your model on you may train your model on unbiased data that is entirely fair, removing fields about race, gender, age, for example, and your model might still see correlations in your data and make discriminatory predictions. There could be proxy variables in your data, so it's important to consider these features that you don't want to be predictive, again, during the testing phase and validation phase. We often think of AI as being automated completely from data sets, but as we've discussed, supervised learning requires labels. While generative AI isn't necessarily supervised learning, these models are refined using human-in-the-loop processes where people interact with the predictions of these models as they're being trained and tuned. The guardrails built into models also require human intervention. If you ask ChatGPT to help you make a bomb, it will kindly refuse. If you ask Stable Diffusion to generate nude images, it will refuse. This is because the model is trained on those images too. All models are trained on data that are in the in class and in the out class. That's the only way it knows the difference. People have to label that data. I'm sure you can think of all the heinous images that AI models will not create for you. People had to look at thousands of examples of those images and label them in order for the model to have these safety measures. And that takes a toll. A for-profit company knows that their data is a very valuable asset. But maybe society should consider the greater good when it comes to this. If we're going to ask people to label this data, they should get extensive support for the impacts to their emotional and mental well-being, be paid a fair wage, and maybe this data shouldn't live with private companies who are independently creating it. And I'm not suggesting this. Sometimes illegal data should be made public, but somehow shared so the least number of people would be negatively impacted by the labeling process. As mentioned, your data should be your most protected asset, not only because it's valuable, which we've seen as the rise of LLMs has gone mainstream, but because it can be exploited by bad actors. Traditional relational databases like SQL, where data is stored in row, column, tabular format, like an Excel spreadsheet, is what many people think of when they think of data storage. The data we have today is different from the data we've used in the past. We now have an abundance of video and audio and image data. And data is now often unstructured, like blocks of text. Sometimes we want to structure the data one way for one project or another way for another project, which would lead us to choose something called a data lake instead of a database option, where instead of defining those columns for our data when we receive it, we define the schema for this data when we retrieve it from storage. This creates a new layer of administration at the metadata layer, since you'll need attributes to search by that aren't necessarily content of the files. This requires a fair bit of commitment to prevent a situation where you can't find the data you want to retrieve, which is sometimes referred to as a data swamp. Many organizations are getting into a situation where disparate data sets are stored by people creating or using them. But when we need to retrain a model or recreate a report, we need to be able to find that data again. This is where your governance practices and policies will be really important. If we're using models in our production system, we want to be able to access data the models need in the format that they require. Getting data and formatting it appropriately, especially if it is not created by your internal systems, is not trivial and should be seen as important and valuable. The assembling of these data sets for any task is innately linked to the success of the outcome. Guardrails that you'll want to consider as AI becomes more prevalent include clearly disclosing when the public is interacting with AI, keeping records of when and how AI has been used in the decision-making process, especially in public services like law enforcement and social benefit programs, and ensuring that when AI is used in decision-making processes, we can explain why AI made the decision it did. AI shouldn't be the sole decision maker, just an input to a decision. And we should also ensure public access to an appeals process for these decisions. Both public and private sector are now opting for pre-deployment independent audits for AI systems and independent assessments. Any system processing citizen data should be encrypted in transit and at rest. And there should be clear rules for sharing data across agencies and with private vendors. The best practice for using citizen data is an opt-in policy for explicit consent to participation in AI products. An additional best practice, sorry.
Sorry, I just wanted to ask you a little bit about the opt-in, because that's been a big kind of point of debate here with some of our data privacy bill, just our broader or non-AI focused data privacy bills. And how does opt-in work for the use of AI? I'm trying to figure out what that looks like. Like if I go to use a chatbot, would it say, this is an AI generated chatbot? Are you okay with that? And I click? Or what? I guess I don't understand how it works.
Yeah, I mean, for that example, it would sort of just be like letting somebody know before they type something in that they're using an AI application. The opt-in really comes in before you even train your model. This is like, if we were going to specify a model on data for people in Vermont, like that traffic pattern data, we'd want to, I don't know, you could send an email or a letter to people letting them know that their traffic patterns might be, or their driving might be used in an AI model and get responses. You could do some kind of survey. That's just off the top of my head.
Yeah, it's worth thinking about because, I think one of the things that I find so alarming is just what feels like the utter loss of control we have over our data, where it's gathered and how it's used and what becomes of it, and how once it's out there, it's out there. So,
yeah, especially with data on the internet. We're talking about like a government where you have access to maybe video footage of driving. That's one thing. But of course, when you're on the internet, every time you use an application, they're watching you and, signing those service agreements and terms. When you use any application and give it information, you can't use it unless you give them your data, right?
right.
And that data has real value, which is why we're using it for free. It has monetary value.
Yeah, absolutely. An additional best practice for governance is an AI oversight committee with cross-sector representation and some technical and non-technical members. This committee should be aware of all AI products and services being created and used so the policies can be consistently upheld. AI literacy will improve everything from use to cybersecurity to efficiency, but I don't think it's a fair expectation that everyone understand how every AI application works in the way that everyone doesn't understand how each pharmaceutical works. A good AI policy should balance openness for accountability with privacy by design, especially when governments handle large-scale citizen data. So turning to sensitive data, with written consent, monitoring the use of public web applications on employer-provided devices is appropriate to prevent sharing sensitive data. The better option to prevent this would be simply to block the websites for popular web applications interfacing with large language models to enforce compliance with a policy that only internal tools should be used. The risk here with any website is that as soon as you submit text, and sometimes as soon as you enter text, the host of that website has captured what you have written. And we've already sort of touched on this, but if the tool is free, it's because you and your data are the product. These companies capture and store this data to improve their application via training or tuning, and many times also sell it to advertisers for profit. So a prominent example of this is when a Samsung employee pasted meeting notes with confidential information into ChatGPT and asked it to generate a PowerPoint for them, thereby exposing proprietary information to an external service. There should be really clear guidelines about how and if these services can be used by employees, because after you've pasted into an external service, you've as good as posted that information on LinkedIn. You just don't have control of it anymore. I should also mention that if you do host your own language model, like your own version of ChatGPT that you want employees to use, you give up data by allowing your employees to access outside models. That data can also be captured by the employer to improve the model they're hosting and provide better service, customized to employees' needs, or even alert the employer to training opportunities. The message I really want to leave you with here is that governance will never slow you down. It's a superpower that will allow you to scale responsibly.
Questions questions on this slide?
Yes.
That sounded like a summary statement, so I thought you had no more slides left. This is really Rep. Sibilia. We're not in a hurry here, so as long as we're staying on track. Rep. Sibilia.
Related to this slide, anything you would say to us about the consideration happening federally for a 10-year preemption on state data governance or AI governance?
Oh, I'm not familiar with that.
That was
Shannon, or-
yesterday's bad news.
Yeah, this is coming out of Congress on Capitol Hill right now. I don't think that we are in a position to make a policy statement yet, having not read through it. And also, we generally don't make policy statements. I think informally, the lesson I take from Rachel's slide is that we need to be ahead on issues or we need to be ahead of the curve, or in fact are already behind it. So we need to make some adjustments now. And on surface level, putting a ban on states taking action doesn't appear to be consistent with that. But I can't say specifically to that legislation.
Thank you.
Just a couple more slides here. I wanted to put something in here about tech hype and buzzwords, because I think we all hear these a lot. So just to go through these, you'll hear it's plug and play. This implies that there is no integration or training effort, and that's just never true. It works out of the box when they haven't seen your data, and probably neither have you. 10x efficiency, this is never backed by real data or benchmarks. An AI first organization, this is an organization that designs with machine learning capabilities as a foundation and not a feature. They see AI as a competitive differentiator or a key innovation enabler. However, an AI first mentality can introduce complexity prematurely, add cost, without considering more appropriate right-sized options. It requires a lot more data to be acquired, organized, accessed, and perhaps labeled. And these products tend to be black boxes, hard to explain, hard to debug, and they introduce more regulatory and ethical risk than a well-defined expert system. AI native systems are often misnomers for marketing. Most products start without AI and then add it later. Bias-free AI, nothing is bias-free when data is collected for a purpose. Bias-free AI is flatly impossible. Real-time, many times real-time just means fast, and it's not the technical implementation of real-time analytics, which requires expensive and specialized software. Anything claiming to use the most mainstream models is probably creating what we call a wrapper, like a candy wrapper around existing functionality and charging you a premium for that. Usually the wrapper doesn't add much value, but they tell you it does. This actually is even additionally sneaky, because it means that they're using the API, and all your data is being sent to the company that's hosting that model, just like if you were putting it into a web browser. Autonomous agents suggest full independence, but many times these are just expert systems with logic written by developers behind the scenes and a user-facing chatbot. Zero trust AI is borrowed from security jargon, and it's usually just marketing fluff. Just remember that a lot of these solutions that seem too technical to be explained are actually just a stack of linear regressions in a trench coat, and start asking questions. And I have a slide here for some questions that I think we'll be distributing these slides. I just wanted to put these out here. My hope for this session was that there was enough information to help you ask the right questions when discussing AI. I won't read through all these, but I just wanted you to have them. In case you're in a place where you want to start having a conversation and someone starts telling you about something that seems too good to be true, you can start figuring out if it is.
Rachel, will we be able to get your slides?
Yes, I think we'll be distributing them, right, Phil?
Yes.
Great.
Yes. And then the last one here, this is a common reframe in the AI community. If you're trying to attract investors, it's artificial intelligence. If you're trying to hire the best workers, it's machine learning. And if you're implementing, it's linear regression. And this is just meant to show that the tech industry really takes advantage of the fact that most people writing the checks don't know what they're really buying. And we should be more discerning about the products we're spending money on and not overpay for hype. Thank you.
Can we have some book recommendations?
Oh, you want some right now?
Well, I mean, you put it out there.
Okay, right now I'm reading a book called AI Snake Oil. I'm actually in Boston for a conference this week, so I got the audiobook for it. It's written by Sayesh Kapoor. It's been really good. It's really new. And I just read a couple weeks ago, I just read a book. I like to try to read AI books that are written by people who don't work in AI as much as I read books that are written by technical people, because I like to get like sort of the take of other industries. I read a book called The AI Mirror by Shannon Valor, who is a philosopher, and that one was really good. And then my favorite book that I always have to plug is a book about data bias called Invisible Women by Caroline Criado Perez. That one's a winner. My favorite book of 2023.
Yeah, I really appreciate the ethical framework that you're wrapping this entire conversation in. I think really it probably matters more than anything else. So I appreciate that approach.
Thank you.
Do we have questions for Rachel? And are folks okay to just keep forging ahead? We'll probably need to take a break maybe between module 2 and 3 or something, just a quick, if folks need to use the restroom or something, but I think we're probably okay to keep going now.
Okay, so let's see if I can figure out how to share my slides. What did I do? Let's go back here, make sure it's, no. Hopefully I didn't delete my slides when I just tried to share them.
That would not be great.
Yeah, that would be, yeah, that in everything I say for the next 25 minutes, you'll be like, okay, he doesn't know anything. Okay, the share button is right here. Come on. Go. And there it is.
Say it's a sign of how bad most software is that very sophisticated tech people struggle to find the share button.
We use Teams, and I noticed that the share buttons, all the buttons seem to be in the exact opposite part of the screen from Teams. I don't know if it's on purpose.
So can you see that?
We can see your screen, but we can also see the whole slideshow on the left.
Okay, now can you see just the slide?
Yeah.
Okay. Okay, Rachel is heading out to a conference, so thank you so much, Rachel, for your time today.
Thank you, Rachel.
Thank you, Rachel.
Thank you.
Thank you.
Okay, good morning. My name's Phil Sussman, and I'm the president of Norwich University Applied Research Institutes. And I've been working in the area of cybersecurity or information operations, information advantage, cyber defense, offensive cyber operations for about 30 years at this point. And I led the development of the cybersecurity programs at Norwich University, as well as developed the Norwich Artificial Intelligence Center just a couple years ago. Rachel gave us a great overview of artificial intelligence, and the speed it is evolving is overwhelming. We have conceived of the power of computing for decades, but it's only been 2.5 years since the large language model ChatGPT was released in November 30, 2022. Since that time, we've seen dozens of additional models released and tools developed. Glasswing AI, a company that's working on an AI firewall, tracks AI large language models and has identified more than 5,000 unique IP addresses attached to these live models operating on the internet today. And remember, these models are built upon millions or billions of parameters to take months to train. The positive is it makes us more productive, maybe, or at least that's the goal. The negative is it lowers the bar for malicious activity and opens up entire new lines of deceit, theft, crime, and nefarious activity. AI has a dual impact as a technology is employed to automate attacks, search for and find new vulnerabilities, create new attack vectors. AI is also automating our defense, manning the firewalls 24/7, providing greater granularity to identify suspicious and anomalous behavior, and providing greater scrutiny of new code and programs before deployment. So I want to thank you for allowing me to come here today to have a conversation about the current state of cybersecurity and the challenges and opportunities it presents. And I'm going to cover some underlying concepts and suggest some places we need to focus our attention to keep us all safer. So just a second to set the stage here, because in some of this may be obvious, and I might not even need to address it, but I just thought we really need to understand that we are a digital society and that technology is mediating much of our lives. It underpins our societal functions and supports the operation of our critical infrastructure. In Vermont, technology and connectivity has created opportunities for small businesses to compete nationally, internationally. Broadband and cellular coverage provides access for remote work. And today, of course, we're meeting virtually. I was meeting with a small nonprofit business that is operating a consulting operation off a dirt road in Orange County. There's no cellular coverage at the home, but they do have fiber because of recent investments in that, both in the state and nationally. We were discussing functionality of a website, and I asked about how was the router set up in the home. Well, that was not the word to use because router was a foreign concept. What is a router? And what do I need to be concerned about what security is out there? And do I need to be concerned? This was a really nice person who was worried that if you were sitting in front of their house and didn't have cell coverage, you wouldn't be able to tell where they are. And so they had left an open port or an open Wi-Fi so that people could gain access to maps if they required them. And that leaves a whole bunch of new sets of issues related to this. But this is a common theme I see all too often. I'm small, I'm too rural, I'm remote. I do not have enough money to make me a target. I'm a small nonprofit. I can't possibly be a target. Cybercrime is much like any other business. The threat actor is searching for the activity that provides the highest return on investment. Yes, the large banks have significant dollars to steal, but they also have significant investments in defending those assets, increasing the cost and raising the barrier on the attacker. The attacker looks for opportunities that takes the least cost to monetize the investment in technology, time, and connectivity. During my conversation with the rural landowner, we actually took a look at what was coming across the router, and there were several cameras that she didn't recognize that were attached. That may have actually existed prior to her taking ownership of the house. So I'm concerned for small businesses. I've talked with manufacturers around the state, and the cost to comply with cybersecurity standards like cyber maturity model certification or the emerging requirements to do business with the United States Department of Defense is daunting and cost prohibitive. And it refers to confidential but unclassified information, which could mean simply the terms of the contract you signed or other details related to your engagement with the Department of Defense. And how do these small companies continue to be able to compete and organize? And when we're talking about small companies, some of these manufacturers might have 70 or 80 employees. So when I say small, I'm not necessarily talking about 2 or 3. Outside of today's discussion, but maybe something to revisit in the future, is that constant connection that the digital natives or our children enjoy. This connectivity provides us with comfort and awareness. After dinner in the summer in Rutland of my childhood, my brothers and I and kids in the neighborhood would get together for a game of hide and seek or basketball, and we would run around the neighborhood waiting for the 10 of 9 whistle and then return home. I think many times when I was during those summers, my mother would actually say, "Get out of the house now." And we would get on our bikes with a group and sneak into Echo Lake in Wallingford. If you know the geography, that's 14 miles from where my house was on a bicycle. Large companies are monetizing the attention or eyeballs using algorithms that sponge up time, and over time may limit the ability of children or others to concentrate and engage with difficult material. On the threat side of the equation, we have a growing threat environment. In the past, hacking took a significant amount of time. And so to be able to work through the attack chain, you need to have some level of sophistication to be a hacker, because the actual kill chain that you were going through had 7 steps in it. You had to be able to scan the web for the knowledge of systems and servers and border defenses and be able to identify the vulnerabilities so you could lay your plan of attack. You would have to decide how you were actually going to deliver that product. Was it going to be through a phishing email, or you're going to leave a USB in a parking lot? What other ways in which you would actually gain entry to that first system? And then once you got there, exploit and gain that initial access, that beachhead, so that you could move laterally across systems and to be able to move to the specific target of the system, and then be able to install and establish a persistent foothold on the target. Command and control is something that we need to be able to continue to maintain our persistent contact within that environment. We think about botnets. When people talk about botnets, which might be 12 or 15,000 computers, there are command and control servers which are sending information to those computers to take specific sets of actions. And you want to be able to keep that consistent control. And then once you get into your objective, you want to complete your mission and execute for that activity. But what we're seeing today is cyber attack marketplaces that are allowing less qualified people, a terminology that has come out in the last probably 5 or 6 years, script kiddies, who could purchase and execute exploits without that same level of expertise. But the marketplace has also evolved with specialization. When you build a house, you need plumbers and electricians and carpenters, drywallers, landscapers, excavation, all those different pieces necessary to build a house. Well, that specialization has now worked its way into the cyber crime, cyber threat environment. So an individual can focus on a single skill and then through cyber marketplaces be able to monetize their specific skill in the same way that a plumber only works on plumbing and doesn't address the electrical systems. So you might have someone who has an ability to develop the very best way of gaining access, or has spent time building the open source intelligence components necessary to be able to then sell that so that folks can attack specific areas. And the interesting part about this is that some of this access can persist for months or for years. And we were reminded of this based on a recent attack on shopping sites such as payment.com that involved a malware that existed inside systems for more than 6 years, unidentified. And recently it was woken up and it's been stealing credit card and other credential information. We also know that a couple of years back, that there was a set of hackers who sat inside a South African bank system long enough to understand the way in which the arcane information system operated, so that they could not only steal money, but they could create money as well as be able to steal it. So then when someone would go to an ATM machine to extract funds, it wouldn't show up as a debit in your account, because the money would be debited but immediately put back. So there was no track of the actual activity that took place. So far, the threat has been characterized, or what we've been characterizing is really criminal or organized crime. But we also know that nation state cyber offensive activity is active and ongoing. Nations like Russia, China, North Korea, and Iran are developing capabilities and actively conducting offensive cyber operations. The intent of these operations was often described as intelligence, surveillance, intellectual property theft, cybercrime, and of course, destruction. One of the earlier events of destruction was the Saudi Aramco that destroyed 30,000 computers attributed to Iran. The recent UVM cyber attack, I guess it's not recent anymore, 5 years ago in 2020 was estimated at 63 million and destroyed a number of endpoints. Within the past month, the former director of Cyber Command and NSA, General Paul Nakasone, U.S. Army retired, stated that the current campaigns are currently directed at the U.S. critical infrastructure to destroy the technology and collapse civil society. So on one side, we have growing resilience on digital systems across all sectors. And on the other side, we have a growing threat environment and more sophisticated attackers, which require us to be more vigilant. Now, I've been doing this for a long time, as I mentioned to begin with, and when I started this, I was sometimes described as hysterical. Would that be the right word? Maybe hysterical. And often people would say, you know, can you show us the proof of this? Much of that proof might have been protected information that you could only hear about or find out behind the door. Or businesses were actually not required to report, or they hid the information on breaches. A number of years ago, I was working with about a dozen financial firms to practice how they were going to respond to a breach. And we were located in a large room with tables. And we had one large financial organization that was sitting there with 6 or 7 professionals clustered around a lawyer. And across the room, there was another organization, and they were trying to be able to communicate back and forth at that point in time to say, you know, what is happening? Are you seeing the same effects? What's taking place? Because we're trying to show how you actually partner. After being pressed, one of the gentlemen stood up and yelled across the table, "Hey, are you getting our messages?" And the lawyer said, "We don't disclose any information about cyber events, cyber attacks, or any sort of cyber security issues." And so the whole idea of practicing went away. But I got to tell you, it's not really the environment we find today, because it's in our face on a daily basis in terms of the breaches that take place. So if I start with the contestant.
I have a question. Sorry to interrupt. Rep Bailey.
Yes, I'm just trying to back up to that transaction you said that was happening at the bank, that they took the money out of the account and then put it back. And what was the end result? Just to say that they did that? Or
They stole $30 million through ATMs in Japan, and they believe the people who were doing the collecting of the ATMs. Can you imagine trying to pick up $30 million through ATMs? It was done by over one night, and they believe that Japanese organized crime were the ones who were putting the cards in and out of the ATMs and collecting the money. And at the end of the day, their balance sheets didn't show anything awry, but their ATMs were empty.
wow.
Yeah.
Thank you.
I'm sorry if I wasn't clear on that.
Oh, that clarifies it. Thank you. Sophisticated back up the balance sheet.
So I just want to hit on one important word here. On this slide, I talk about contested homeland, and really, that's a terminology that you would never hear. I've done a lot of work over the years with the Department of Defense, and in particular, working with Army Installation Command. And a year ago, I was presenting at a conference in Washington, D.C., and the term that was used by the head of Installation Command, a lieutenant general at that point in time, was contested homeland. And I heard it multiple times that at this moment in time, all interactions on the internet, even in the United States, are contested. So there's a recognition that this actually takes place. We also know that our critical infrastructure is interconnected and dependent on other critical infrastructure. We found out that a gas pipeline, when it gets cold and there's great demands on electricity, needs electricity to continue to operate. And that provides the fuel to run the generators, it provides the electricity, and you could have a cascading failure with the loss of electricity and the inability to bring the electricity back because the gas pipelines didn't allow you to start or cold start that system. So often we look at and we practice from a single company or element of critical infrastructure. We've done about 120 cyber exercises with organizations in the past 14 months at this point in time, we being Norwich University Applied Research Institutes. And what we often find is you have a singular organization that is practicing their incident responses within their organization, but they're not necessarily looking at those supply chain or value chain components that they're going to require to be able to fight through any sort of activity. So it's important to think about those dependencies, and it's a recognition now that we need to think beyond us. How are we going to engage with law enforcement, or if appropriate, with civil support from military authority or from some other way to be able to do this? And we need to be able to practice these activities. And I've been involved in a couple of large-scale ones around, particularly around installations. We know that response to cyber incidents require practice. How successful is a football team that never practices? Relationships must be developed, gaps understood, dependencies identified, and risk accepted or mitigated. People change jobs, organizations employ new technology and systems, relationships and dependencies evolve, and organizations must continue to exercise and practice response and recovery. In January of 2023, the Chinese commercial bank was hacked. And at that point in time, they shut down the technology for them to be able to execute their treasuries, purchases, and sales. At that moment in time, there was something on the magnitude of $150 billion, give or take a nickel, that was not going to be executed, which could cause significant liquidity problems within the overall financial markets. A series of exercises called Quantum Dawn had created a playbook for organizations to come together and to be able to actually execute against these types of activities. And they were able to move the dollars into the treasury and execute their process regardless of the fact that their systems were down for several weeks. So developing that practice and preparing and planning, identifying the gaps, and figuring out how multiple organizations can play, this has been going on for a number of years. Operational technology, sometimes referred as cyber-physical systems, are vulnerable. Those systems are open and close valves, turn on pumps, open and close contactors, and manage our HVAC, our heat, ventilation, and air conditioning systems, as well as our security systems within our buildings, are no longer on closed networks. They used to be within a closed network, and therefore we're not vulnerable. But now we use the internet to connect with those systems to be able to monitor and manage those systems, and then again, they become vulnerable, like the rest of our technology. And the rise of IoT is in the ability to plug and play devices and cameras into networks continue to also allow us to introduce vulnerabilities within our systems. And finally, most importantly, is that this is not an IT problem. And we've come to realize that this is really a whole organization. It's culture, it's operations, it's leadership, it's process and tech to be able to engage and communicate and survive a specific cyber event. So I want to talk a little bit about cybersecurity in general and cyber resilience. Where's my clock?
It's 10:22.
Okay. So I might want to pick up. I might have been going too slow. Let's see. But anyways, let's talk for a second about cybersecurity and cyber resilience. And oftentimes when we think about cybersecurity, we think about protecting systems, networks, and data from digital attacks. And we have a NIST cybersecurity framework that we think about cybersecurity, and oftentimes when we started doing our journey with cybersecurity, we really looked at the identify, protect, and detect components within this framework. And of course, you can't put in place a cybersecurity policy unless you know what you're attempting to protect. And you must be able to identify what are the specific assets within your organization. And I have a couple slides on cyber risk. And ultimately, you need to be able to understand what are your systems and what are your assets to be able to protect those, and to be able to think through how you're going to and what are the most important things to work on at any moment in time. As Rachel talked about governance and AI, governance policies are important within the cybersecurity environment. In December of 24, I see here on this other screen I have over here that the Vermont Agency of Digital Services produced their Information Security Foundation's policy, and within that they talk about much of what the purpose as well as the scope of it of those activities are. So to be able to understand what you're protecting, you must be able to have a business environment analysis. And your goal is to build a strong foundation by knowing your vulnerabilities and what needs to be protected. And then that leads us to protecting. And within that protection, we know that we're going to develop and implement safeguards. And that's really the barriers to keep people out or to limit access to our data and our systems. So that's going to limit the impact or contain the impact of a potential cybersecurity event. So if we look on this in the policy pages, I'm looking here to my left, we can see that there are things like access control, configuration management, contingency planning, identification and authorization. All those are elements of our protect strategy within our organization. I also know that I know that the state of Vermont is going through a significant network upgrade at this point in time, making a huge investment to be able to put in a robust across government system that's going to have in place those elements necessary to be able to limit access to technologies and data and components, to be able to actually put the borders around the edge of our technology, to be able to look at each one of the endpoints and to manage those component pieces. So ultimately, we're attempting within this place to minimize the likelihood of successful attacks and then raise that cost or barrier of entry or raise the cost of a cyber attack on our organizations. Unfortunately, we can't rely simply on putting the best locks in our systems or limiting who has access to our systems. We also need to be able to have a robust activity to be able to detect. So that would be to identify the occurrence of a cybersecurity event in a timely manner. And how are we going to be able to do this? Through things such as continuous monitoring, looking at the devices that are being used, when they're being used, being able to look and see whether or not there has been intrusion or some activity that shouldn't be operating, be able to look at across our different systems at the security event logging analytics and determine whether or not those systems have been inappropriately used. This also requires not only detecting, because up to this point in time, a lot of the stuff we think about we think about protecting from the outside. We also need to be constantly vigilant based upon insider threat and being able to look at when is the appropriate use of a particular activity, or is someone now accessing a set of services outside of a normal time and something we should be concerned about? Or do you have someone actually accessing a set of files or systems that they don't normally have a requirement to do to complete their job? Those are all elements of an insider threat plan. And then we start to fall over on this whole concept of cyber resilience. And that's really the ability to prepare for it. I like to use the term, and it may be inappropriate, but the term which is, can you take the first punch and survive it still standing, to be able to then recover from that activity and as much as possible ensure continuity of operations. So within the NIST cybersecurity framework, we talk about respond, and this is really building that incident response planning, activity, and execution that is actually outlined in your this policy promulgated in December. What are going to be the communication protocols? How exactly are we going to communicate with all the different levels within the organization? How are we going to communicate with the board or with legislature and the other people responsible for the oversight of these systems? How are we going to interact among the organization? How are we going to react within the larger public? What is taking place? And of course, how we're going to talk to our clients about the impacts that'll take place with those. What is the actual incident that's taking place, and what are the mitigation steps to limit that impact? And ultimately, what you're attempting to do within that respond capability is to assess what's taking place and then be able to have a set of steps necessary to be able to respond to that incident, and as much as possible to prevent escalation. Then we get to recover. And recover is about restoring capabilities or services impaired by a cybersecurity incident. I've read a little bit about the UVM event that took place, and the most one of the pieces that was most concerning of UVM at the time was that they only had 3 days of appointments laying in front of them, and they had to be able to figure out how and what resources they needed to look beyond that time period, and actively being able to restore the capabilities that were of the hospital system at that point in time. So how do you create the planning and execution, restore the sets of systems? If systems are destroyed, how are we going to actually replace those systems? A recent significant network upgrade that was involved on campus here, some of the gear took 18 months for it to arrive from a major manufacturer, from the point in time an order and the check being written. So the equipment may not necessarily exist out there. So you have to think about, through your systems restoration, what are those, back to that original identify construct, what are those most important systems, and what investment are you going to make in spares to be able to do that? And then, of course, post-incident reviews and lessons learned. For a number of years, I was involved in some exercises, and we would have this annual exercise. And at the end of the third exercise, this would be 3 years in the early 2000s, we found that the lessons learned mirrored previous lessons learned. So I started to use the terminology, we had lessons observed. Because lessons learned, if you look at the cyber resilience activity on the right-hand side of your slide, cyber resilience means that you're going to evaluate the lessons learned. You're going to be able to then integrate those within your planning and rethink through that process of how are you actually organized to be able to actually respond to and recover. And in some cases, this may be the most important thing you do, because today, unfortunately, the number of cyber incidents that take place in actual penetrating those systems is significant. And in the words of one former director of Cyber Command and NSA, it isn't that when you will be attacked, if you will be attacked, but when you will be attacked and succumb. So ultimately, this cycle is not linear but continuous. It's a wash, rinse, repeat construct that needs to be ongoing to be able to make sure that you're operating in this manner. Did I hear someone ask a question? Because I don't have a picture of the room.
I don't think so. We'll give you a heads up when we're. I'll interrupt you politely.
Thank you. I appreciate that. So from when we go back to that construct about really what are the risk considerations, risk is a potential loss from a threat that impacts a specific vulnerability. So that's how we want to think about what our risks are. Now, it could be simply the loss of critical data, and that could be publicly identifiable information or healthcare, personal information, but it could also be intellectual property. Probably the greatest theft in the history of the world was intellectual property theft by China from the United States higher ed and research communities, as well as the defense industrial base. We also, but it's also the loss of operations and the ability to actually, in the UVM case, run the hospital. I'm sorry, I'm not meaning to pick on UVM. It's just upper mind at the moment. And of course, then what are the cascading or the knock-on effects? And we talked about losing electricity, which then would eliminate your ability to actually stand up electrical power. We know that in segments of the United States, there might be one black start based power plant within an entire sector. That meaning one plant that if power goes away, it can actually start and generate power so that then you can bring the sector back onto to line and bring the power back. So what is the cascading effect that could take place if you lost one of your pieces? So thinking through what those tangible risks are, but unfortunately, risks aren't just simply tangible, they're also intangible. And reputation. There is some suggestion that Target has never really quite recovered from its cyber breach that took place a number of years ago. And I haven't checked to see this is valid, but I keep seeing it pop up in presentations, but something on the magnitude of 60% of small businesses that have a significant cyber impact never come back. I'll say that with a grain of salt. I've heard it a number of places. I've read it online, but I have not verified that. But I do know that cyber impacts, I have watched how cyber impacts have shut down organizations that take place. The other piece simply is just the human factors or the emotional impact. If you go without power for 2 days in Texas in the middle of winter, that has a number of impacts that take place that are less tangible, or just simply the emotional impact that goes through this. There's a lot of, it turns out that chief information security officers are kind of like forward observers in Vietnam. They have relatively short time periods. And the reason for that is there's a tremendous amount of stress put on them as they battle on a daily basis all of the risks and realize they don't necessarily have the necessary resources to be successful. And finally, trust with the organization, or trust that these services will be available over time. So it's important within that consideration. We know that from a risk standpoint, what we're trying to do is really prioritize what are the business functions that are operating, and then that will engage a stakeholder involvement. This particular slide is one that we use in a Federal Emergency Management Agency course that we give, and it starts to look at not only from a business standpoint, what are those sets of activities, but also think about this from a community standpoint. And how exactly are you going to identify from the community's perspective exactly what is important and how to prioritize those business functions over time to be able to continue the operations in an ongoing way. Then it's important that once you have that you put in place those set of mitigations based upon the highest level of prioritization of those specific functions that take place. So you've identified the risk, and then you're attempting to develop strategies to reduce that risk and implement a number of different things. You might put in place role-based security to limit access to information and processes. You may only allow access to authorized users to do certain functions within activities. You may only allow individuals to be able to make changes. And by doing all that and continuously monitoring that ongoing activity, then you're able to regularly review and look at what this risk profile looks like. My question I have, and I've asked this a number of times, just where among all of the risks does cybersecurity rank within your organization's acceptable risks? Oftentimes you'll find it trapped within the IT department as something that they feel is very important, but is it shared more widely by the whole of the organization? And does and does the organization as a whole understand the impact that could take place within that cybersecurity environment? So some things that we need to work on at this moment in time that I would suggest, and yes, I guess I went a little faster than I thought, but cyber is a team sport, and therefore it must be practiced as a team across multiple dependencies, and we need to think about it holistically across the organization. It's not simply an IT related problem or the chief information security officer's problem. It's actually the entire organization, and beyond that, it's the ecosystem in which we operate. When I go back to that quantum dawn based activities, the whole of the finance sector, those people who were responsible for the liquidity of our financial markets understood that if a particular activity took place, if there was an event that took place, if there was an inability to be able to process significant or systemic interactions, then holistically, the marketplace had to come together and be able to solve those problems. And it might be one organization that has the capability in that moment in time to be able to step in and stop the system holistically from collapsing. So cyber is a team sport, must be practiced that way, and we need to think outside of our individual organizations and more holistically at the communities in which we operate. I say that trust cannot be built in a vacuum, and that really builds on cyber as a team sport because you can't create trust at that moment in time when you have a crisis. It's so important to be able to have those relationships. The first time you meet your FBI agent shouldn't be in the middle of an event or to determine whether or not some set of resources exist within your community or within the state or beyond. So you want to be able to have those relationships in advance and be able to understand how you interconnect in your dependencies and build that trust over time within that whole ecosystem that goes forward. We can't say this enough. Cyber hygiene, good password quality, using multi-factor authentication, not broadcasting or using the same password on multiple sites, making sure you shut down your browser on an ongoing basis, making sure that you lock up sensitive information on a daily basis. All of those components of cyber hygiene that you would expect. Don't click on that link. As much as you'd like to see that picture, don't click on that link. And really, just because someone tells you that you're brilliant and wonderful and attractive, that they want to connect with you and learn from you, doesn't really mean that they aren't working for a nation state attempting to extract information, or a cyber criminal to be able to do that. So cyber hygiene and the way you interact with your computers and your systems is so critical, and we have to continue to do that. And then building a culture of cybersecurity is really required within an organization, and that starts with the leadership of that organization. They have to make sure that they project that cybersecurity is important, as well as every leadership element within the organization, and develop that culture and refer to cybersecurity on an ongoing basis. We know that we have a significant workforce shortage. I'm not being self-serving completely on this as someone who works near a higher ed institution. By the way, one of the two higher ed institutions that are National Security Agency Center of Academic Excellence qualified in the state, our friends up north in Chittenden County at Champlain College. But we do know that there is a workforce shortage. We know that there's a skills gap that exists, and there's opportunities to find ways to fill that skills gap. I think when we talk about artificial intelligence, if I bridge the two areas, I think we need to think our way through the whole construct of how are we going to roll out and introduce this changing technology across K-12 and the workforce at large. And there is a emerging AI council education working group that is starting to figure out how exactly to identify what those skills gaps are, and then possibly what are the responses to that through actually engaging with industry and business across the state of Vermont. But there is a workforce shortage that exists within cybersecurity at this point in time. And then, of course, we know that cyber resilience is dependent on testing plans and people on an ongoing basis, and to be able to engage in that. So that's the presentation that I have to talk about cybersecurity at this point in time. Do you have any questions that you'd like to look at? I guess the one other piece that I would suggest, when I was looking on the website, I found the 2019 cybersecurity strategy for the state of Vermont. And in that strategy for the state of Vermont, which I must admit that I was part of the working group that wrote that one, and we identified at that time that that in particular our municipalities and school districts and small critical infrastructure within the state of Vermont needed additional support and services to be able to harden their defenses and to be able to go through that whole process to be ready to respond. I looked at the most recent one, which I believe was delivered to the legislature in January. I might have the dates wrong on that. I apologize. I saw that recommendation was again something that was critical to be able to do. So I would suggest that that we need to think holistically about how we're going to get our municipalities and our school districts to be able to protect their systems and their data, that they are possibly in some cases low-hanging fruit. I've over the recent couple of years worked with a couple of municipalities and police departments, and for the most part the technology is not current, and in some cases I'm just concerned about its efficacy in this particular environment. And we've seen nationally that there have been a number of attacks on police departments in particular through ransomware, and we've seen a number of municipalities attacked in different ways to be able to gain access to both money and information. So I'll take a breath at this point in time.
That was really interesting. Do we have questions right at the moment? Yeah, Mara?
I know there's firms, and you might do this, that assess vulnerabilities from the outside, as if they were a hacker and is that something that's expensive, useful, or would be useful in this kind of a context to assess our state or municipal vulnerabilities?
I believe that the state of Vermont, and please, you'll have to check with the Agency of Digital Services. I'm not representing them, but I'm pretty sure that the state of Vermont does penetration testing on all of their statewide networks at this time, and uses that information to then address their protection schema or the way they're organized. So that's something that is ongoing at the state level. So I don't believe that all municipalities do that type of activity. In many ways, this is kind of like the conundrum of the big and the little, right? So JP Morgan, Jamie Dimon says, if I need to spend $1 billion on cybersecurity, I'm going to. A small bank may not be able to spend the same amount of money to protect their systems to be able to do that. when you look at the Duke Energy or other large firms, they spend extraordinary amounts to protect their systems and distribution networks. In some cases, we know that rural electric cooperatives might have one person who's a part-time network administrator and responsible for the configuration of their information systems and operational technology systems. And so the smaller organizations, and therefore I would assume by reference, the municipalities are probably the ones at the greatest risk. Did I answer your question or successfully avoid it?
Yeah, just to clarify terms, when you say penetration testing, you're meaning someone from the outside, not the same entity that's setting up the protection scheme.
No. Penetration testing is usually done by a third-party provider,
Right.
and they will use current technologies. There's a number of automated technologies, and do it to imagine a. See, I'm going to make myself an old, define myself as older, I guess, at this moment in time. Gunsmoke, at the end of the day, Matt Dillon walked around and checked all the doors and windows and made sure they were locked and closed and looked in the windows and that sort of stuff. Penetration testing is done not by the owner of the store, but by an external entity to make sure that common controls are in place and that any known vulnerabilities are identified and exposed, that type of activity. And Nuwari does do this commercially, is what Sherman just sent me a note.
Thank you.
I'm not trying to sign up for a. I just want to make sure you don't think I'm obfuscating, but we do that.
Yeah.
All right. I think it might be good if folks are okay for us to take a 10-minute break so that people can run to the restroom or whatever. And then let's rejoin you right at 11. And at that point, we'll go off YouTube and enter executive session for the last leg of our training. Does that sound okay?
Thank you. We'll be standing by.